Good morning, students. All will do the remaining problems in the moving charges. Hmm. See, okay. See, a long solenoid has 200 tons per centimeter, carries a current I. The magnetic field at the center is 6.28 into 10 power minus 2 Weber per meter square. Another long solenoid is having 100 tons per centimeter. It carries a current I by 3. The value of magnetic field at the center is what? So what they did, current changed, number of turns are changed. Magnetic induction at the center of the solenoid formula B is equal to mu naught Ni. Already mu naught is constant. So B1 by B2 is equal to N1 by N2 into I1 by I2. This B1 value they gave 6.28 into 10 power minus 2 by B2. Number of turns initially 200. Now it becomes 100. Current value I. Now it becomes I by 3. Okay. These two zeros will cancel. I will cancel. 3 will goes to the numerator. It becomes 6. So B2 is equal to 6.28 into 10 power minus 2 by 6 approximately. This is 1.05 into 10 power minus 2 Weber per meter square. So options will be third option for this. Okay. Next, see the next question. Cyclotron in which protons are accelerated has a flux density 1.57 Tesla. B value will be 1.57 Tesla. What is the frequency in cyclotron? Frequency formula F is equal to BQ by 2 pi m. Here B value will be 1.57. Here proton is accelerating. Charge of the proton will be 1.6 into 10 power minus 19. 2 into 3.14. Mass will be 1.67 into 10 power minus 27. Okay. So 1.57 2 times will cancel. This 1.6, 1.67 approximately it will cancel. So 1 by 4 into this will be 10 power 8. So 0.25 into 10 power 8. Now F value will be how much means 2.5 into 10 power 7 H. Okay. So third option will be answer for this. Okay. See the next question. Oscillating frequency of a cyclotron is 10 megahertz. Frequency they give. Radius of the D's they give. F is equal to 10 into 10 power 6. 10 power 7 H. Radius they give 0.5 meter. Kinetic energy of the proton will be how much? That is the question. Kinetic energy basic formula Ke is equal to half mv square. We know m, but we don't know v. If we calculate v, we can calculate kinetic energy. So we'll use a time period formula. T is equal to 2 pi by omega. So 2 pi by this value will be V by R. So this is 2 pi R by V. Okay. Uh, T is equal to 1 by F. 1 by F is equal to 2 pi R by V. V is equal to F into 2 pi R. F value 10 power 7. 2 into 3.14. R value will be 0.5. 2 into 0.5 will be 1. So here velocity we will get it as V is equal to 3.14 into 10 power 7 meter per second. Then kinetic energy Ke is equal to half mv square, half into mass value 1.67 into 10 power minus 27. Velocity value we got it as 3.14 into 10 power 7 whole square. This value is in actually in joules it will come. And to get this value in MeV, in electron volt, see all answers are in MeV. So what I am doing is 1 by 2, 1.67, 10 power minus 27, 3.14 into 10 power 7 whole square by MeV means 1.6 into 10 power minus 13. Minus 19 will be EV. MEV means 10 power minus 13. If you calculate finally this value, we will get it as 5.1 MeV. So Ke value here answer will be comes in MeV. So this value will be 5.1 MeV, 93rd, it will be fourth option. Okay. See the next question. A charged particle Q is moving in a circle of radius R with uniform velocity speed V. The associated magnetic moment is how much? A charged particle is there, it is moving in a circular path. Circular path radius will be capital R. Then what is the associated magnetic moment? Magnetic moment formula M is equal to I into A. I is equal to, we can write it as QV by 2 pi R into area value will be pi R square. Actually, I is equal to Q by T ma, Q by 2 pi by omega. This is Q omega by 2 pi. Omega is V by R. This is equal to QV by 2 pi R. Omega is V by R. If you substitute, I is equal to QV by 2 pi R. Pi will cancel, 1 R will cancel. So this is equal to QVR by 2. Capital R they give. So this will be QVR by 2. See the next question, what they are asking. Two particles each of mass m, charge q, are attached to the two ends of a light rod of length 2r. The rod is rotated with constant speed about a perpendicular axis passing through its center. The ratio of the magnitudes of the magnetic moment of the system and its angular momentum is. So here there is a rod. Okay, there is a rod like this. Then at the ends of the two rod, two charges are placed here and here. Mass M, charge Q. Here is also mass M, charge Q. Length of the rod will be 2r. Okay. Here, this rod is rotating about this axis with some angular velocity omega. Then magnetic moment and angular momentum ratio is how much? That is the question. Magnetic moment formula M is equal to I into A. So here I is equal to total charge by time period. Total charge 2Q na QQ are there na charge. So that's why it becomes 2Q. Time will be 2 pi by omega and this value will be pi r square. Q2 will cancel, pi will cancel. Therefore, M is equal to Q r square omega. This is equation 1. Next, angular momentum formula will be I omega. So 2mr square, they gave capital R, na? Capital R or small r, whatever it may be. Here also you take capital R then. Here also it will be capital R. 2 into mr square into omega. So m by L is equal to Q r square omega by 2 into mr square omega. So this value Q by 2m. R square omega will cancel. So this value will be Q by 2m. This is the first option. Okay. Next, 104. What they are asking. A particle of mass 0.6 kg having a charge 25 nanocoulomb. Here a particle is there. Its mass is given, charge is given. Moving horizontally with some velocity in a magnetic field. The value of the magnetic induction is. So it is moving uniformly means its weight is balanced by the force. Write that point. Since it is moving horizontally. Actually, because it is a magnetic field, what will happen? Its path will turn. Its path is not turned, means weight is balanced by force. Mg is equal to BQV. Then B is equal to Mg by VQ. Here M value will be 0.6 into 10 power minus 3. And G value will be 10. V value will be how much? 1.2 into 10 power 4. And the charge they gave it as 25 nanocoulombs. Okay. If we calculate this one, finally we will get B is equal to 20 Tesla. Simple calculation you do. We'll get it as 20 Tesla. Option for this will be third option. Okay. Next, see the next question. The time period of a charged particle undergoing a circular motion in uniform magnetic field is independent of its time period is independent on time period formula is what T is equal to 2 pi m by BQ. So mass dependent, charge dependent, magnetic induction dependent, speed independent. So 121, it will be first option. Next, 127, what they are asking, see, H plus, He plus, O double plus, all having same kinetic energy. All they are having the same kinetic energy. Passes through a region in which uniform magnetic field perpendicular to their velocity, masses of H plus, He plus and O double plus are 1 AMU, 4 AMU and 16 AMU. Then among them, which will be the correct options? So here what will happen for H plus? First we'll write the formula for kinetic and the radius. R is equal to mv by bq. This is p by bq. This is p value root of 2m ke by bq. So R proportional to root m by q. They give same kinetic energy. Na? Kinetic energy remains constant. They are moving in the same magnetic field, in a uniform magnetic field. All are moving in the same field. B will be constant. So in this formula, Ke, B are constants, are proportional to root m by q. So for H plus R is equal to some constant into constant will be same only for all of them. Mass they gave it as 1 AMU. Charge will be 1 plus 1. So this will be 1. For helium plus R is equal to mass will be 1. Charge will be, mass will be 4, charge will be 1. This will be for O double plus. Mass they gave 16 units. So charge will be 2 units. So because O double plus is there. Here He plus is there. That's why only 1. So this is equal to 2. So from this what we can say, H plus will deflect more because when a deflection is more, then only radius will be less. So this statement is correct. O plus, no, the second statement, O double plus will deflect more, no. He plus and O double plus will deflect equally. This is also correct. Why? Because for both of them, radius came as 2 units. All will deflect equally. This is wrong. So A and C are the correct options. 127, it will be fourth option. Next, see the next question, what they are asking. A proton is moving in a perpendicular magnetic field, possesses kinetic energy E. The magnetic field is increased 8 times. By the proton constrained to move in the same, but the proton constrained to move in the same radius, kinetic energy will become. So R is equal to, just now we discussed, 2m ke by bq. Okay. Here what they are asking is kinetic energy and magnetic field relation is what? It is constrained to move in the same path means radius same. Same proton means M and Q are constants. So here R, M and Q are constant. So root Ke proportional to Q. Ke1 by Ke2 B Q constant. Na? So this will be B. B1 square by B2 square. Okay. So this is E. Na? This will be Ke2. This is B. B2 becomes 8B whole square. This is 1 by 64. Ke2 is equal to 64E. Kinetic energy will become 64 times. Okay. See the next question. Two long wires are hanging freely. Two long wires are hanging freely. They are joined first in parallel, then in series. Two wires are there like this. Initially, they are joined. This is first wire. This is second wire. These two wires are joined parallelly. Okay. So what will happen when they joined parallelly? Same current will flow through them. Same, see, currents will be in the same direction, not same amount of current. Currents will be in the same direction. When currents are in the same direction, wires will attract. In the second case, what they gave is here one wire is there, first wire. Here second wire is there. They joined here and they joined in series means like this they connected. So here current is like this, in this current is like this. Here when currents are in, when are in opposite directions, they will repel. So first case they will attract. When they are in parallel, they will attract. The second case they will repel. In series, they will repel. First option will be the answer for it. See the next question. An arbitrary shaped closed coil is made of length L, carries I ampere, is flowing in it. If the plane of the coil is perpendicular to the magnetic field, force acting on it is one closed coil like this, any closed coil, any shape. Its area vector will be perpendicular. So, what is the force means? I into L bar cross B bar. Here L bar and B bar are parallel to each other. So F value will be equal to how much? Parallel vectors cross product will be 0. So force will be equal to 0. 147, it will be first option. Okay. Next, see 150 question what they are asking. Three long wires, three long straight parallel wires are shown in the figure. The force experienced by 10 centimeter length of the wire will be. The force experienced by 10 centimeter length of the wire. And see, here currents are in opposite direction. So they will, the force experienced by 10 centimeter length of the wire Q is. Okay. So these two currents are in opposite direction. They will repel. I am assuming that force is F1. So F1 is equal to mu naught by 2 pi I1 I2 L by R. Mu naught by 2 pi value will be 2 into 10 power minus 7. Currents are 20 and 10. They gave here 20 and 10. Length is 10 centimeter. So 10 power minus 1 meter by distance is 2 centimeter. 2 into 10 power minus 2. This 2 will cancel. So this value will be, see here, 10 power minus 8 minus 2 minus 6. It will be 2 zeros are there, 4. So 2 into 10 power minus 7 newtons. Next, F2 value. Between these two also currents are in the opposite direction. So they will repel with each other. Then F2 is equal to how much? Same formula. Mu naught by 2 pi. I1, I2, L by R. This is 2 into 10 power minus 7. Here I1, I2 values will be 10 and 30. This value 10 power minus 1. By distance value 10 centimeter means 10 power minus 1 meter. So this value 6 into 10 power minus 5 means 0.6 into 10 power minus 4. So what will happen? Which is more? F1 is more than F2. Then F net is equal to F1 minus F2. 2 minus 0.6 into 10 power minus 4. 1.4 into 10 power minus 4 Newton. This is acting towards the right. F1 is more, na? That's why it is acting towards right. So 150, it will be first option. See the next question, what they are asking. 153. In the given loop, when current is flowing in this direction, what will happen? That is the question. Okay. See here how to do. Here dot field is there, na? Dot field. That dot field unit vector will be k cap. Here I am taking a point here. Here it will be like this length vector. Here it will be like this. Here it will be like this. Here it will be like this. Length vectors. Field will be always in the k cap. Here first I am taking here. This one first I am taking. So there what will happen means F bar is equal to I into L bar cross B bar 1. So just we are finding the direction only. So L bar here in the top, L bar is along the x-axis. Positive x-axis unit vector will be I cap. Magnetic field will be always along outward means k cap. I cross j is k is equal to minus j. So minus j means it will be along negative y-axis. So here, how it will be there means it will be in this direction. Here, if we calculate second point, in second, what will happen? F bar is equal to, here current will be, see, downward, minus j cap, length will minus j cap, cross k cap. Then j cross k will be I. It will be minus I cap. Minus I cap here means it will be like this. Here if you calculate here, this will be, length will be minus I cap. I cross k will be minus j, minus into minus plus j. So here it will be, here plus j means upward. Next, fourth, if you take, length will be j cap, positive x-axis, y-axis. J cross k will be I. So here I means it will be like this. So all will try to contract that loop. So loop will tend to contract. Okay, simple question. Next, see 161, what they are asking. A square loop carrying a steady current I is placed in a horizontal plane near a long straight conductor carrying steady current. Steady current I, this is not 7. Steady current I at a distance d as shown in the figure. The loop will experience. See, in this currents are in the same direction. So it will attract this one. Attractive force will be there. Currents are in the same direction. These two are perpendicular. This one and this one are perpendicular to this one. On them, no force will be there. This one and this one, if you calculate, currents are in the reverse direction. They will repel. Because distance is less, force between the two charged conductors. What is the formula? F by L is equal to mu naught by 2 pi I1 I2 by R. Here R value is more between these two wires. Between these two wires, R value is less. So what will happen? Attractive force will be more than repulsive force. Here, attractive force magnitude is more than repulsive force. So therefore, wires will attract. Okay, this is the answer for it. Okay, see the next question. A rectangular loop. Last question. No? We'll finish this session by closing this question, discussing this one. what they are asking. See, rectangular coil is there. Coil will be 100 tons. Length and width are came. It is placed in a magnetic field. Current is given. What is the torque acting on it? Torque formula will be tau is equal to BIAN sin theta. B value we have to find. Torque value will be 0.2. B into I value will be 2. Area 5 into 4 into 10 power minus 4. Number of tons 100 into sine 90. So B is equal to, if you calculate, finally this will be 2 by 4 will come, means 0.5 Tesla. 174, it will be first option. Okay. With this, we will close this session. At least minimum, you try to learn these questions. All are important, very, very important questions. You try to learn these questions. Okay. We'll stop this session now and we'll continue the remaining in the next.